Hello, ladies and gentlemen. Welcome back to yet another episode of Learning with Junaid. Today, we are going to be talking about an interesting problem asked in multiple companies. So, the question goes something like this: given a circular list, implement an algorithm which returns the node at the beginning of the loop. So, that's one of the algorithms. The second thing, or they might also ask you, check if the linked list has a loop. So to give you a better example, I'm going to open up this diagram. So you see, this is the linked list. Each of this node A, B, C, D, D to E, F, G, H, I, and I goes back to D. So this is a circular loop. So they might give you a linked list like this, and they might want you to ask, implement an algorithm that will give us D1. And the second thing is, try to find out if there is a circular loop inside this linked list, either of these two cases. How do we do this? There is an algorithm. It's called as the Floyd Cycle Finding algorithm. We are going to implement this, a memoryless approach, to find out how we can solve this problem. The Floyd Cycle Finding algorithm is based on the tortoise and a hare strategy. The way he says is, you always maintain two pointers that point to the same location, and then start the slow moving pointer one block, and then move the fast moving pointer twice to the slow moving pointer. So it's like a tortoise and a hare running on a track. So eventually the faster running hare will catch up with the tortoise if they are running in a loop. So to give you a better example, I'm going to open up this diagram and I'm going to talk to you like this. So let's assume that this is a tortoise and this is a hare. The first time the tortoise will be standing here. Since the hare is faster, he would be standing here. Eventually, the next time tortoise comes here, hare would have already moved here. When tortoise comes at D, hare would have moved at G. When the tortoise comes at E, hare would have moved at H. So you see, every time the tortoise moves one block, you have to move your hare from whatever it was at G, you move it 2 blocks. So the next time tortoise moved at F, your H would have moved from H to D, I to D, D to E. So H would be here and tortoise would be here. So the next time tortoise moves from F to G, your H would move 2 blocks since he is running at twice the speed. So he would move from E to F, F to G. So at this point G, your tortoise and your H would meet. So this is called as the meeting point. So if there is a meeting point, that means this is a circular loop. That's one of the conditions that we will try to satisfy. So how do we do this? Let's go back and look at this diagram. And he says, so we have to first find out, the first part of the algorithm is find if there is a circular loop in your list. I have defined this linked list according to the diagram that you see here, A, B, C, D, E, F, G, H. Let me go ahead and run this program. I will call this method display list, which is going to print out the values in this linked list. If this program is run, I'm going to go into an infinite loop. Let me stop this, because you see, from I to D, and then it just goes into an infinite loop, right? So now we need to find out if this is a circular loop. I mean, just by printing out an infinite loop, you can't tell to an interviewer saying, oh, this is an infinite loop, this has to be a linked list. No, that's not how it works. You need to write some kind of an algorithm, right? So we are going to use a Floyd algorithm. So the Floyd algorithm into very simple step is 2 pointers, one at normal speed, other at twice the speed. At some point, both the pointers will eventually meet. If they meet, then it's a circular loop. So one at normal speed, let's name it as tortoise. Twice the speed, let's name it as hare, right? So I'm going to go ahead and implement this algorithm. Let's see step by step how we are going to be able to solve this. So I wrote a method. In this method, I have a blank method right now. Let me go ahead and cite. Let's say. So if they both meet, they have to meet at point G, right? So that's what I'm trying to find out. Let's see if I say I'm going to maintain load list node. Let's say tortoise is equal to head list node hare is equal. They both are starting at the same point. Now I am going to say while my hare or my tortoise in each of this next node is not equal to null. Oh, just an example. I am going to the second part of the program. I was actually supposed to go to the first part of. First I have to determine if there is a circular loop. The logic is the same. Let's say tortoise is equal to head list node head is equal to head. They both start at head. What I am going to do is I am going to say that while my hare dot next node is not equal to null, I am going to move my hare at twice the speed. Okay, and I am going to move my tortoise at normal speed. Make sense? If at some point, if my tortoise and my hare meet, that's the same node. They'll meet at point G in our case. Return true. Otherwise return false. So very simple. I iterate until one of this could be either tortoise or it could be hare, it doesn't matter, but this matters. One should move at twice the speed, the other one should move half a speed. If there is a circular loop, they both will meet at some point. That means they both will meet at a point like this. I just showed you here. Here, right? Let's go ahead and try to comment this. I don't want to display it. I'm going to comment this. I've still not implemented the second part and find if this is a circular loop. The linked list has a loop which is true. Simple. Okay, now the next part of an algorithm, sometimes they might also ask you if there is a loop. If this is true, then find the beginning of the loop. Floyd. How do you do that? Okay, so I'm going to implement the same algorithm but this time instead of returning a through or a thing, the Floyd algorithm talks if they meet, then it's a circular loop. If you determine the meeting point, then move the tortoise to the start of the head and move both the hare and the tortoise at same speed. Example, let's say that you are at G, so this is a place where you move that, right? So what you're saying is take T now and move it at the front here. So move H one by one, both at the same speed. So until you have a node where your tortoise and your H will have the same values. For example, you will move T from here to here and here will be standing here. Now this time, the next time, move them at the same speed. So first time it will come here, hare will come here. The second time it will come, the tortoise will come here and the hare would have come here. The fourth time the tortoise would have come here and the hare would also be here. Here at this moment, make a check if your tortoise and hare are at the same list node. This is a node where the circular loop starts. So how do you implement that? Pretty simple. Go ahead and say find the beginning of a loop. Start the same logic again. List node tortoise is equal to head. List node hare is equal to head, while my hare dot next node is not equal to null. We are going to first find the meeting point. Let's see what's a meeting point. I'm going to find the meeting point, we have to go to the previous method. I could have just called the previous method, but I'm going to just write it again anyways. Hare dot next node, and then my tortoise will move at same speed. I'm going to assign it to this tortoise and I'm going to assign this to the hare. If my tortoise equal to hare, then I found the meeting point, right? Instead of now returning true or false, I'm just going to say break. Okay, so it will break at G at this point, because this is the point where both will meeting, right? So now what we do is, according to Floyd, you take the tortoise and you put him back to the front. So you say, hey, I want to make tortoise, I put him at the front, the head. Okay, now go ahead and say while hare dot next node is not equal to null. So this is a check just to iterate further. Hare dot next is next, because there is no next node which is null anyways. You see, this condition by itself will go into an infinite loop. So there has to be one more check inside to make sure we come out of this loop. So what Floyd says is, once you take one of the pointers, once you find a meeting point, take one of these and put it at the front, and the other one and this one should now move the same speed. So same speed is next node tortoise, next node here. Oh, sorry about that. They both are going at the same speed. At some point, your hare and your tortoise will be at the same node. that will be D. Return tortoise or return head, return hare, because it doesn't matter because they both are standing at D, right? I'm going to return null here anyways, it doesn't matter. Let's go ahead now, uncomment this. I'm going to run this program. I hope I have not made a mistake. I think I understood that correctly. This moves twice, this moves at same place. You find the meeting point, you break. Let me debug it. No, let me just first run it and make sure it works. Okay, the linked list has a loop. The meeting point. Oh, the point of the loop is D. Okay, so is D the point where the loop starts? Yes, fair enough. So I'm going to go ahead and show you by debugging what happens. First, let's go to this method, find if there is a circular loop. You see, you move it at twice here and tortoise at one speed. The place where they both meet here, the value is G. Tortoise, the value is G. G is a place where they both are meeting. If one of them moves at twice the speed of the other one, according to Floyd's cycle finding algorithm, right? The second one is if you have found out, then it's saying okay, there is the linked list has a loop which is true. The second one, go ahead. So you know this part, finding a meeting point. You found the meeting point now. While hare.next node is not equal to null, this could be tortoise or hare, doesn't matter. The one thing that matters is you want to make sure that once you find a meeting point, you take one of these and put them at the front. It could be hare or it could be tortoise. In my case, I just took tortoise and put them on the front. And when you find a meeting point, Floyd says they both have to move at the same speed. If they move at the same speed, they will coincide at the looping point. You see, here and your tortoise both coincided at D. So that's how it is. This is a very simple algorithm, very efficient, and point them out. This I could have done this in a brute force way also. Last night I did, but then I didn't want to show it to you because I found this algorithm very easy and very efficient, and also I found out that this was being asked in multiple companies, so I thought I will just share it with you. Pretty simple. If you just go through this chart again, you would understand. Move tortoise and hare at different speeds until you find a meeting point. Once you find a meeting point, take a tortoise or a hare and put him at the front, and take a tortoise or a hare, the other one that is standing here at the meeting point, move both of them in the same speed until they both are pointing to the same node. If they both are pointing to the same node, that's the node where the loop starts. So in our case, if you go ahead, run it again, the point of the loop for us is D. So that's your Floyd algorithm, and I hope you liked the video. If you have any questions, if you have any comments, please let me know. Otherwise, please go ahead, and if you like this video, just click the like button. And if you have not subscribed to my channel, please subscribe to my channel, and let me know if you would like to hear something else, or you would like to learn something else. And I don't need this. And until then, next time, I will see you soon. Thank you again. Bye-bye.